find the value of y. So this length here, we're trying to find the length of this triangle. When dealing with similar triangles, it is always a good idea to redraw the triangles so that the corresponding sides match on the diagram. So if I turn this triangle upside down, I can draw it out over here, and I can keep this one as it is. So now I can see that this angle and this angle match up, the bottom left angles, and this angle and this angle match up, the bottom right angles now. Y matches up with side 12, so they are corresponding with each other. And 30 matches up with side 18, so they are corresponding with each other also. So these triangles are similar. Again, we start with the unknown side being y, and put it over the corresponding side which we do know. So y goes over 12, so y is the numerator, 12 is the denominator, so y over 12. Then we take 18 and we're going to put it over 30, so 18 is the numerator, 30 is the denominator. So y over 12 is equal to 18 over 30. Then all we have to do is cross multiply and solve. So cross multiplying, y multiplied by 30 gives us 30y, and 12 multiplied by 18 gives us 216. Then solve for y, 216 divided by 30 gives us 7.2. So y is equal to 7.2. Be very, very careful when you're doing these questions. If you had written y over 12 equals 30 over 18, it would be completely incorrect. The y and the 18 both have to be the numerators. So y and 18 are both the numerators. And the 12 and the 30 both have to be the denominators. So 12 and 30 are the denominators. So y over 12 is equal to 18 over 30. So 18 over 30, cross multiply and solve. Now the y over 12 could have been on the right hand side and the 18 over 30 could have been on the left hand side. Or we could have had 12 over y equals 30 over 18, or 30 over 18 equals 12 over y. Doesn't matter which way we have it, so long as one of the triangles, let's say for example the smaller triangle, both of their values are either both the numerators or both the denominators. And likewise with the larger triangle, doesn't matter which way we have it, so long as both of their values are either both the numerators or both the denominators. So in this particular question, we have the y and the 18 as the numerators, the 12 and the 30 as the denominators. So it's y over 12 and 18 over 30. Find the length of AE, so this length here from A to E, and the length of DE, so this length here from D to E. So let's start with part 1, finding the length of A to E. So we know what the top length is on the left, and we know what the bottom length is on the left, and we know what the bottom length is on the right, and we're trying to find the top length on the right. So we can use our formula, top length divided by bottom length equals top length divided by bottom length. So top length divided by bottom length equals top length divided by bottom length. So the top length is going to be AE, and that's going to be divided by the bottom length, which is 3, and that's equal to the other top length, which is 4, divided by the other bottom length, which is 2. So we have AE over 3 equals 4 over 2. Now we could have wrote it the other way around. 4 over 2 equals AE over 3. Doesn't matter which way we write it because we're going to cross multiply. So we're going to multiply AE by 2, which gives us 2AE. Alternatively, we could have labelled AE as x, and then we would have had x multiplied by 2, so 2x. But in this example, we have 2AE, so that's going to be equal to 3 multiplied by 4, which is going to give us 12. So cross multiply AE multiplied by 2 gives us 2AE, and 3 multiplied by 4 gives us 12. So 2AE is equal to 12, And then we need to solve for AE. So we're going to say 12 divided by 2 is going to give us 6. So AE is equal to 6. What they did in this example was they said 4 divided by 2 is 2. And then they multiplied both sides by 3 so that cancelled out. And 2 by 3 is 6. So it doesn't matter which way you do it. So now we know that AE is equal to 6. And now we want to find the length of DE. So to find the length of DE, it's a good idea to redraw the triangles, but this time to separate into similar triangles. So we have ADE, ADE, and ABC, ABC. Now, if we just start with our smaller triangle, ADE, from A to D, we have a distance of 4. So we're going to label AD as 4 in our smaller triangle. From A to E, we have a distance of 6, because we already found that from part 1. So we label this as 6. We don't know what this distance is here, DE, but that's what we're trying to figure out. We're trying to figure out what this distance is, this distance DE. So then we have our larger triangle drawn out. And if from A to D is a distance of 4 and from D to B is a distance of 2, then 4 plus 2 will give us 6. So from A to B a distance of 6. If from A to E is a distance of 6 and from E to C is a distance of 3, then from A to C is going to be a distance of 9. So 6 plus 3 is 9. So the lengths are clearly different. We have 4 and 6. And then we have 6, 9 and 12. So the base of our larger triangle is 12. But we do know that the angles are all the same, because this triangle is inside of this triangle and their bases are parallel. So this angle here is equal to this angle here. And this angle here is equal to this angle here. And this top angle is clearly the same for both. So that tells us that they are similar triangles. So the angles are all the same in similar triangles, but the sizes are different. But because the angles are the same, the sizes, or the sides, are automatically in proportion. So what we have to do is write down what we know. Well, we have DE, which we could label as X if we wanted to, but I'm just going to leave it as DE for now. DE corresponds with 12. So we're going to have DE over 12. And then 4 corresponds with 6. So we're going to have DE over 12 equal to 4 over 6. So it's very, very important that either the sides on the smaller triangle are all the numerators, or the sides on the smaller triangle are all the denominators, or vice versa with the large triangle. So if DE is our numerator, then 4 is also our numerator, and DE is going to be over 12 because it's corresponding with 12, and 4 is going to be over 6 because it's corresponding with 6. Now we could have used 6 and 9 as well. It would give us the same answer. So once we've set this up, this is the tricky part. Then we're just going to simplify our fraction here. 4 over 6 gives us 2 over 3. And then we can cross multiply. So DE multiplied by 3 is 3DE. Or if we had labelled this as X instead, it would be X multiplied by 3, which is 3X. And 2 multiplied by 12 is 24. So we get 3DE equals 24, or 3X equals 24. So DE is going to be 24 divided by 3. And 24 divided by 3 is 8. So the length of DE is going to be 8. So this length here is going to be 8.